Good morning, ma'am. My name is Sharath Reddy. I am from CSCF section. My topic is evaluate the line integral, where C is the square formed by the lines x is equal to 1, comma x is equal to minus 1, comma y is equal to 1, comma y is equal to minus 1. Introduction to line integrals. Line integrals are used to integrate functions along a curve in a given space. They are particularly useful in physics and engineering, especially in the context of work and circulations. Understanding how to evaluate line integrals is essential for multivariable calculus. Parameterization of the curve. The curve C can be divided into four segments corresponding to the square edges. Each segment can be parameterized using a variable, typically t, to represent position along the segment. We will define parameterizations for each of the four edges of the square. The problem is to evaluate integral over c x square plus xy into dx plus x square plus y square into dy, where c is the square formed by the lines x is equal to plus or minus 1, y is equal to plus or minus 1. Solution. Let f bar is equal to integral over c x square plus xy into dx plus x square plus y square into dy. Given curve is formed by the lines x is equal to plus or minus 1, comma y is equal to plus or minus 1. We can draw the square with four boxes. We can visualize with a, b, c, d values. Integral over c f bar dot dr bar is equal to integral over ab f bar dot d bar plus integral over bc f bar dot dr bar plus integral cd f bar dot dr bar plus integral over dA f bar dot dr bar. This is the equation 1. Along the line segment AB, A value is 1, 1, B minus 1, 1, y is equal to 1, then dy is equal to 0, x is equal to 1 to 1 to x is equal to minus 1. Integral over AB f bar dot dr bar is equal to integral 1 to minus 1 x square plus x into dx. After integration, x cube by 3 plus x square by 2 close bracket 1 to minus 1. We can substitute two integrals. Minus 1 by 3 plus 1 by 2 minus 1 by 3 plus 1 by 2. Minus 2 plus 3 by 6 minus 2 plus 3 by 6. 1 by 6 minus 5 by 6 is equal to minus 4 by 6. We can cancel the values. Minus 2 by 3. Along the line segment BC, B minus 1, 1, C minus 1, minus 1. X is equal to minus 1, then dx is equal to 0. Y is equal to 1 to y is equal to minus 1. Integral over BC f bar dot dr bar is equal to integral 1 to minus 1, 1 plus y square into dy. We can integration after y plus y cube by 3 close brackets 1 to minus 1. We can substitute the values. Minus 1 by 3 minus open bracket 1 plus 1 by 3 close bracket minus 4 by 3 minus 4 by 3 minus 8 by 3. Along the line segment CD, C minus 1, minus 1, D 1, minus 1, y is equal to minus 1, then dy is equal to 0, x is equal to minus 1 to x is equal to 1. Integral over CD f bar dot dr bar is equal to integral minus 1 to 1 x square plus x into minus 1 into dx. Integral minus 1 to minus 1 x square minus x dx. We can integration after x cube by 3 minus x square by 2 close brackets minus 1 to 1. We can substitute the values, limit values. 1 by 3 minus 1 by 2 close bracket minus 1 by 3 minus 1 by 2 close bracket 2 minus 3 by 6 close bracket minus close bracket minus 2 minus 3 by 6 minus 1 by 6 plus 5 by 6. We can cancel the values and solution is 2 by 3. Along the line segment DA, D minus 1 comma minus 1, A 1 comma 1, x is equal to 1, then dx is equal to 0, y is equal to minus 1 to y is equal to 1, integral over dA f bar dot dr bar is equal to integral minus 1 to 1 plus y square dy. We can integration of the y plus y cube by 3 close bracket minus 1 to 1. 1 plus 1 by 3 minus into minus 1 minus 1 by 3. 4 by 3 plus 4 by 3 is equal to 8 by 3. We can substitute the all values in 1 from equation 1. Integral over c f bar dot dr bar is equal to minus 2 by 3 plus 2 by 3. Minus 2 by 3 plus 2 by 3 minus 8 by 3 plus 8 by 3. We can cancel the values and we get integral over c f bar dot dr bar is equal to 0. Therefore, hence proved. Final calculations. After computing the individual integrals, we can combine them to arrive the single value. The value of the integral will be depend on the function being integrated along the curve. It is important to check if the function satisfies the for the application of theorem. Conclusion on applications. The evaluation of line integrals over curves like is the fundamental in vector calculus. Then concepts have applications in physics, particularly in calculating work done by a force field. Mastering line integrals enhances understanding of multivariable functions and their behavior in different contexts. Thank you for giving me this wonderful opportunity.